Hello. I'm gonna do just a handful of questions from lesson 3. So this is algebra revision, exponent rules, as you can see in the top there. But I'm not going to go through everything. I'm just gonna go through some of the exercises, maybe do like a couple, and then move on. So here, this is slide number 6. Slide 6. I'm just gonna do maybe like the last several, right? I'm going to start at number 20. Let's start at number 20. Okay, 3 to the power of 8 times 3 to the power of 11. That's not 11, that's 11. When you multiply two powers, but that has the same base, what happens is this happens. This expression here is the same as saying, and there you go. I wouldn't actually figure that number out. I'd leave it at that, which means at 21, we can say for that question, I wonder if I can zoom in and leave it there. There it is. So 21, I'm going to go 2 to the power of 5 plus 6, which is 11, but I'll do that later. Right, so if you multiply two powers with the same base, the powers add up. I'm not going to explain it. I'm just going to answer the questions for now. If you do want me to explain why that is the case, let me know. But for now, I'm just doing the questions. So that is 2 to the power of 11 times 3 to the power of 6. Now, we can work that out, but for the sake of time, I'm not going to. And I don't think the question wants us to. They just want us to simplify it. So let's leave it at that. 22. Right, so same thing. Even though it is a variable now, we know the same thing applies. Nope, there, 3.5. A to the power of 3.5. So we add the exponents. 23. That becomes 2q plus 3q, which I can simplify that and say that's 5q. Yep. 24. 1 plus p plus 1 minus p. Now I can put that in brackets, but let's say I've already done that. And I know that I want to add a minus p and a 1, so that's just x to the power of 2. That's x squared. Boom. Done. So that's that. When you multiply them, you add the powers, you add the exponents. Well, division, the opposite happens. If you do want to figure out why that is the case, do think about what it actually means. Right, so it's x times x times x to the number of how many that is the power, and then you're multiplying by x to the how many more. So you think about that. You have a try if you want to prove it for yourself. But here we go. I'm going to do starting from 21. This is slide 8. Okay, starting from question 21. Right, so again, similar things happen, but of course, it is technically 7a over 14 there. What happens is that the powers subtract. The exponents subtract. So that's the exponent law. So we know that it's, we can do the number 7 and 14. That's 1 over 2. And then the a, it's just reduced to a over 0, which is just 1, isn't it? Which is just, so half times a over 0, that's just a half. Oh, yep. There you go. If that is the case, the x's cancel out, right? So again, if x's cancel out, it's the same thing as this. This is happening, right? And also I am timesing it by 3 because 9 over 3 is 3. So this is just 1. That's x over 0, which is times 1. So I'm just going to leave it at 3. Question 23. So the answer of this should be, so this is where that law becomes better than just us thinking about canceling it out. Thinking about us subtracting the exponents makes better sense now. Cool. Let's just undo those brackets. So that's q minus r plus q. Remember, I'm minusing a positive r and I'm minusing a negative q. So the signs do flip, which is why I'm plussing the q here. Cool. So all that being said, that is 2q negative 2r, or minus 2r. Yep. 24. So same thing. 2a plus 1 minus 1 minus a. So this is why I do need the brackets, because then I don't want to mess up that negative sign. 2a plus 1 minus 1 plus a. Cool. So that is 3a. And yeah, just 3a. The plus 1 minus 1 makes it go away. It's plus 0. There you have it. Right, moving on to question 10. Powers of powers. I'll just do the last 5. So, this is slide 10. Boop. Cool. And then starting from 14. So we are rewriting this as powers of 2. Now, 4 to the power of 8. Now, we can rewrite 4. We can say 4 is 2 to the power of 2. Cool. So what this becomes is, remember that's separate. I'm going down this line now. What happens is 2 to the power of 2, power of 8. So I have substituted 4. I have substituted 2 to the power of 2 into 4. So instead of saying 4, I put that in. So I do this. Remember, if I do have this happening, it is 2 times 4, which makes it, right? If you have an exponent over an entire power, you have to multiply those exponents. So here we go. Let's try it. 2 to the power of 2 times 8, which is 2 to the power of 16. Yep. 15. 8 to the power of 3. Again, we do the same thing. We think about 8 and what we can write. We can write 8 as 2 to the power of 3 should be 8, right? 2 times 2 is 4, times 2 again should be 8. Yep, so I can rewrite it as that. That is an equals there, which then becomes, boom, 16. 32 squared is the same as 2 to the power of, well, 32, I think, is a 5. 2 to the power of 5 squared. Cool, that is 2 to the power of 10. 17. 16 is 2 to the power of 4. Right? So I'm rewriting 16 as this. I'm rewriting 32 as this. I'm just rewriting that as a base of 2. Now, it might not always be a base of 2, but we have to be able to, you know, if we need a base, if we need it to be in a base of something specific, this is how we would do it. And we're just practicing with 2 in this specific instance. Boom. See, I'm writing less and less now because I'm explaining less. Write 9 to the power of 3 as a power of 3. So again, we do the same thing, but just not with a 2. So I can write 9 as 3 squared. So that's that, which then I can expand those brackets, which becomes 2 times 3, which is 3 to the power of 6. Boom. There you go. Moving on. This is the negative exponent rule, right? But this should work just the same. Slide 12. Let's just do the last 4. Question 30. Right. Now, yep, so we would go minus 9, which is actually a plus, right? So it will be a negative 4 plus 9, which gives us that. Side note, this means this. Just so we know, just so we're clear on that. So this is really quite a weird formula, but if we stick with the laws, if we stick with the exponent laws and we just carry on with it, if you're dividing, we subtract exponents, we're fine. We end up with the right answer. So the laws, they're pretty good. They're handy for us, and they've been made quite accurately. Boop. Let me write the question down. So again, we have negative powers, but we're not afraid of those anymore. Let's do the number first. 24 over 12 is just 2, and it's 2 over 1, but I don't really need to write the 1. And it's going to be x6 minus negative 8, which is 2x to the power of, that's a plus 8, so 14. 32. Well, this is where I stop writing questions, because it's getting long. So 3 over 12 becomes 1 over 4. Yep, yep. The x variable, the exponent is going to be whatever this is. Cool, and the y variable is going to be whatever this is. Right? Cool. Let's write it all in. Y is negative 6. Cool. Which you can write as this, or if you want to be really specific about it, you can say, and all of these 3 answers are technically correct. 33. Cool. We have it in a bracket or a parentheses. So let's expand that first. So if we do expand it, remember the rule, the exponent law is that the powers multiply. Becomes that. Right? The rule is the same, the law is the same. The only fact is that we are multiplying by a negative number. So we're just double careful about that. And you can write this down to be more specific or more neat, however you may feel about it. But yeah, that's the answer. Yep, moving on. It's the last little bit. I'm going to do the last column. Here we go. What was it? Fraction evaluate. Okay, fractional exponent rule. Cool. So now we're on slide 15. In the third column. Just the third column. Let's do all of the third column, shall we? Because it is the last one. So 4 to the negative half. Okay, so we don't really need to do anything about the 1. Multiplying by 1 is just nothing. So we only need to care about halving it. So remember, this thing means it is a square root. So what's happening is the square root, -1. So of course, the square root of 4 is just that. Wait, no, what am I saying? No, my mind skipped. Sorry about that. To the power of -1. And of course, yep, you might want to think about the fact that it is both possibilities, plus and minus. But I don't think we need to worry about that too much here, but we just know that that's a possibility. Now, that just means, and I'd rewrite that as that. Cool. Next one. 2. Okay, cool. 49. And then the same thing. So, well, we can think about the case if we do the negative, deal with the negative first, which makes it that to the power of a half. And, the power of a half is a square root. So we are going, which again leads us to the same thing there. The fact that we do the denominator first, the square root first, is merely a preference. We do whatever makes better sense for us. So we'll see in the example that we have next, this one. Now in this case, we can decide to square it first, square this number here, 125, and then do the cube root later. But the thing is, if you square this, it's just a really big number. And maybe I just don't want to deal with that right now. And hopefully, maybe I can cube root it. Of course, if I can't cube root, then I do have to take the other route. But yes, if I can do both, we see why that's the preferred route. Cool. The cube root of 125. The cube root, by the way, yes. Remember, the squared still remains. Is, I think, 5. 5 times 5 is 25. 5 times 5 is 25. Times 5, yeah. So it should be 5 squared. Because the cube root of 125 is 5. It is not plus and minus 5, by the way. If you cube a -5, you do not get 125. You get -125. So, so this is not double. If it's an odd number, if that power is an odd number, if you're imagining that we're cubing it or to the power of 5, yeah, doesn't apply. Anyway, moving on. Of course, the answer is 25. Moving on. 4. 3/2. Again, let's deal with the denominator first. So let's go that, which is, of course, yes, and we can say plus and minus 2 here. But let's see. 2 to the power of 3 is 8. 8 plus or minus 8. Wait, actually, now that I think about it, no. Our question is not a variable, so we actually shouldn't have 2 possible answers. Wait, let me go back. Okay, this is not true. It should be just 1/7. This should be just a half. Right? Because what this means is because it's, yeah, no, yeah. I guess due to the nature of the question, we're not pondering both possibilities. Okay, never mind. Sorry about that weird moment there. 6 to the power of 5/4. That's a bit weird, but anyway, I wrote that weirdly, but you don't mind, hopefully. Cool. What to the power of 4 gives us 16? We could do it either way, but I do not want to do 16 to the power of 5 on paper without a calculator. It's not something I'm keen on doing. So hopefully I can do that. I believe it's 2. So there we go. There we go. Right, wait, let me just check. Yep, 2 to the times 2. 2 squared is 4. 2 to the 8. 16. Yep. Boom. 6. Number 6. 8. Boom. Yep, again, I'm going to do this first. Just because it's easier in this case. There we go. And 7. Which is, well, 27 to the cube rooting it, which is just a 9, which is 9 to the power of 4. Oh wait, no, not 9 to the power of 4. I forgot the negative. 9 to the power of negative 4. Okay, and I have to do 9 to the power of 4 in my head, actually. On paper, I mean. I can't actually do it off the top of my head. 9 times 9 is 81. 9 cubed would be 972. And then one more to the power of 4 would be, oh, let's see. 81. You know what? I'm gonna fully write it up, because right now I am not very confident in my brain function level speeds right now. Okay, cool. That's 81. That's 0, 1, 8. And that is 0, 0, 63. Cool. I add it all together. And I get 1, 6, 5, 6. Cool. That number there. Cool. So the answer is 1 over 6, 5, 6, 1. I wonder if they would have just taken 1 over 9 to the power of 4. Let me check. Hey, I got it wrong. No. What have I done wrong? Oh, no. That's bad. That is very bad. Now, how many have I got these wrong? Have I got a lot of these wrong? No, it doesn't seem like the case. Okay, I just got this one thing wrong. Okay, that was bad of me. I see. And I see what I've done wrong. Because the cube root of 27 is not 9. It's not 9 at all. See? I told you I'm not functioning as fully as I should be right now. Okay, let's go back to the question. Right. Cube root of 27 is 3, isn't it? Right? 3 to the power of 3. 3 cubed is 9 times, 27. So it should be 3 to the power of 4. Wait, no. 3 to the power of 4, like that, because it's a negative. Boom. And yes, 3 to the power of 4 is 3, 9, 27, 81. Okay, there we go. There we go. Sorry about that. I took us all down the wrong rabbit hole. Anyways, there it is. Those are the answers. I mean, the answers are all here, to be honest, but those are how I would get there, or sort of the couple of lines leading to those answers. Hopefully that helps. And yeah, revise. Let me know if you have any questions. See ya.